Hey, this is Horner, and we are looking at 1981 M1 for AP Physics C. And to start this one, what we need to do is we need to look at our diagram. So we've got this block sitting on an incline, and there's a force pushing it to the right. So we think that that should push it up the hill. Is there any friction? Yeah, there is. It says there's a coefficient of sliding friction, so we've got to worry about friction here too. Let's go ahead and draw all the forces on this. We know that straight down we have mg. We know that we have a normal force which points up this way of N. We know we have a force going in this direction that is the force of friction. And then we have another force pointing this way, which is F. So we're going to transfer all of these right onto our diagram. So we've got N, we have F going to the right, we have the force of friction trying to keep it from going up the hill. And then finally we have mg. Really important that you draw arrowheads on each one of these. Really important they all come from the box. And very, very important that they all have a label on them that's appropriate. So 1, 1, 1, and 1. By labels that are appropriate, let me show you some others. Fn could also be here. This is probably F or FAPP, some sort of applied force. MG could also be FG or it could be W. But typically I like to see MG here, N here, F, and then a little f. This one could also be force of friction or it could be mu N. So any of those things would be appropriate. I like to try to keep things simple. It's sometimes good to have them all with the F on it, but then it gets really confusing later. So that's why you typically don't see that all the time. For the next part, it says it wants us to develop an expression in terms of m, the angle theta, f, mu, and g for the block's acceleration up the plane. So we're going to try to figure out what is the value of a. So this gets to be pretty tricky, so make sure you pay really good attention to what's going on. What I would do on the test, if this one's on the test, is I would draw the plane, and then I would draw a dot for our object, and then I would just go to it with the different forces that are there. We know that the normal force is here, so draw all the regular forces that we had before. We have F this way, going in the downward direction is mg, and then finally we have a force of friction which is going in this direction. Because it is accelerating up the plane, we want to make this direction to be positive, and this is our acceleration. So we could say if we had if we wanted to add some sort of axes, we're going to say that this is positive perpendicular and that this direction is positive parallel. So those will be really important. Now, because we're not on letter A, because you don't want to do this on letter A, they'll take points off, we're going to draw all the components that we need. And we want all the components to be in two directions. One of them will be perpendicular and one will be parallel to the plane. This angle right here is theta. We know that the angle of the plane was also theta itself. And then we've got to have 2 for F. So there's one, and the other one just rides right along the plane. If you do that, this angle is also theta. So now let's go ahead and I'm going to move my mg over. I'm going to make my eraser a little bit smaller here. It's a little bit too big for what I need. So I'm going to move my mg over to where it really belongs, which is right there. This F is probably okay. This side is going to be the opposite side of the angle. So it's mg times the sine of the angle. This is the adjacent side, so it's mg times the cosine of the angle. This is the opposite side, so we're going to say that this is F times the sine of the angle, and this is the adjacent side, so this is F times the cosine of the angle. Now that we've done that, let's do the sum of the forces in each of the directions. So this is the sum of the forces in the parallel direction, and that's equal to ma because we know it's accelerating. But let's do the one that has the smaller number of forces in it, and that is the perpendicular direction. And we know that it's not accelerating up or down. It's only left or right. So there is no acceleration in this direction. What is it that's going up the plane? In this direction it is the normal force, so we say N minus, now we've got F sine of the angle, and we also have mg cosine of the angle, and that's equal to 0. So now we're going to say N is just equal to F sine of the angle plus mg cosine of the angle. All we did was we added f sine of the angle and mg cosine of the angle to both sides to get the n all by itself. Now we're going to tackle this other side. So we know going up the hill we've got f times the cosine of the angle. Anything else going up the hill, this is the only one I see that's traveling in the same direction. So now we're going to subtract the force of friction as well as mg sine of the angle. So, oops, need to back this up a little bit. So minus f minus mg sine of the angle, and that's equal to ma. So I'm going to look again. I've got f cosine of the angle, and then the only two things in the other direction are mg sine of the angle and f. So let's go ahead and expand this one a little bit. We're going to say, we're going to just move everything down here. F times the cosine of the angle minus f. Now remember, f is actually equal to mu times n, and we've got n. So let's put mu times f sine of the angle plus mg cosine of the angle. So that takes care of this, minus mg sine of the angle, and that is all equal to ma. So at this point, we need to solve the expression for a. So I'm actually going to move a to this side and then move everything to the other side. So we've got f cosine of the angle divided by m. Now we also have this expression. So what we're going to do here is let's go ahead and multiply both of these by mu. So we're going to have minus, and then we're going to have mu f sine of the angle plus mu mg cosine of the angle. But remember, we're dividing this whole thing by m, so we're going to have this divided by m, then this m will disappear or get crossed out. So now we've got mu g cosine of the angle, and then we've got minus mg sine angle divided by m would be minus g sine of the angle. And that is our expression for the acceleration. This part is worth 7 points. And the reason it's worth 7 points, obviously, is because it's a pretty big problem. You get 1 point for saying this, 1 point for saying that. So that's 2 of the biggest points. You get 1 point for solving for n. So now we're up to 3. You get 1 point for this, 1 point for this expression, and 1 point for this one. And then the last point is correct algebra to get the expression, which is kind of crazy, but they must have ran out of points. So they want to make sure you have all the intermediary steps in order to get there. And that's it. So that is part B. Let's go on to part C. Part C now says that we have a force. They want us to find the magnitude of the force that would allow this thing, here we're going to move this back up, to slide up with a constant velocity. So what does that mean? That means that we need to know that acceleration is equal to 0. So the sum of the forces in the parallel now are also equal to 0. So if we go back and we pull in that drawing that we had again, we've got mu n going in this direction. We know that in this direction we have, this side was f cosine of the angle. We know that this side of the triangle for this f was f sine of the angle. We have mg pointing down, but then we have two sides of the triangle. This is mg cosine of the angle. This is mg sine of the angle. I'm trying to do this fast since you've seen it before. And then this is n. So we already said that n is basically very simple to do. It's just equal to mg cosine of the angle plus f times the sine of the angle. Those are the two things that oppose the n that you see here. And now we need to rewrite our expression for the sum of the force. So we know the sum of the force in the parallel direction is equal to 0. So let's write all those out again. we have f times the cosine of the angle, and then we subtracted from that, um, we subtracted from that mg sine of the angle and mu n. So we're just going to go ahead and put them on the other side. So we're going to say this is mu mg cosine of the angle, okay? And then we need to add to that mu f sine of the angle plus mg sine of the angle. Okay, so where did all that come from? This is f cosine of the angle is going up the hill. Going down the hill was mu n, but remember n is mg cosine of the angle plus f sine of the angle. So we just multiplied mu in front. So let's go ahead and I'm just going to backtrack and show you that. So this is f cosine of the angle is equal to, and this is mu n, and then plus mg sine of the angle. So the n then is this stuff, and so now we can, you can kind of see where all that came from and where we're going to go next. So at this point, we need to get both of the f's on the same side. So we're going to subtract mu f sine of the angle. So f cosine of the angle minus mu f sine of the angle is equal to mu mg cosine of the angle, and then we add to that plus mg sine of the angle. We need to get the f's all by themselves, so f factors out. We have cosine of the angle minus mu sine of the angle, and that's equal to mu mg cosine of the angle plus mg sine of the angle. Now what we're going to do is divide both sides by cosine of the angle minus mu sine of the angle, and we are going to factor out the mg's. So our final equation is, we've got mg factor out on the top, and then we have mu cosine of the angle plus mg, oops, sorry, I factored that out, and I'm trying to put it back in. I don't want to do that, times sine of the angle, and that is divided by cosine of the angle minus mu sine of the angle. So now we've got that expression, but it says for part C, what is the relationship? So we've got this relationship, but now we're going to say that f has got to be bigger than 0, okay? And so now we could say that the cosine of the angle has got to be greater than mu times the sine of the angle. So therefore, if we divide both sides by u and then divide both sides by cosine of the angle, we're going to cross these off, this is cosine of the angle. Now we're going to say 1 over mu is equal to tangent of the angle. And that's really 1 over u is greater than tangent of the angle. So that's the relationship. This part's easy to get, but then this part's a little bit harder. We need a force that will allow the block to slide up the plane. So we need just a little bit more than 0. You need like 0.0001 force in order for it to go up. Otherwise, A equals 0 here just means that we haven't gotten it started yet. So here we just need a little force to get it started. And so this is the relationship, kind of a weird thing. If you don't get these 2 points, that's fine. This right here is worth 2 points. And I know it's a lot of work for 2 points. So anyway, the whole thing's worth 4. And that is the end of 1981, mechanics number 1.